This is quite a short lesson, so a short video here, but in this video you're going to understand how one might classify coasts in different ways. Hopefully from your work during the last lesson you realise that the main sort of types of coasts are rocky and sandy, but these are very generic terms, and coasts can be classified in many other types of ways. So we'll be looking at how to classify a coast as and the key term spots here: high energy coast, low energy coast, what a discordant or a concordant coastline is, and examples of discordant and concordant coasts from around the world. So before we move on, I want you to have a little think, just to sort of recap on what you did last lesson, to make sure you understood the factors that affect the coast. So we talked about it in lesson 1, but maybe pause the video here, list as many factors that affect the coast as you can think, and then sort them either by colouring them in or just putting a B or a G or an M or whatever into these categories. So biological, geological, geomorphological, meteorological, hydrological and human factors. So pause the video here, do a little revision kind of thing, try and remember, and then categorise them into these categories that are here. So here we are, welcome back, and you can see here that we this is a slide you've seen in an earlier video, and we have a number of, we have the factors here that I asked you to separate your factors into, and hopefully you got all of these things in your kind of revision session. So if you didn't, maybe it's worth going back in your notes and having another look at this and making sure you can list all the things that affect coastal areas. So if we look at this slide here, we can see a number of different coasts around the world here. We can see a port in the centre there, container port, a few tropical islands down here, the bottom left, and then sort of over here at 3 o'clock we've got Door in Dorset, which is a very famous sea arch. Here we have a kind of quite a flat estuary kind of area. It looks like an estuary with some fishing boats. Here we have a lovely shingle beach here with some fairly collapsed sandstone cliffs there, and here we have typical beach sand dune. But how might you classify these coasts? I mean, you might look at these pictures and think, right, well, okay, this one's rocky, that one's rocky, all the rest of them are not. Or you might think, oh, these are affected by humans and these ones aren't, but is that entirely true? Or you might think to yourself, oh, these have got hard rock here in this one, and these ones have all got soft rock. So there are many ways to think about how you might classify coasts, but we kind of narrow it down for you so you don't have to think about all of them. And here is some ideas that people come up with for how we might classify coasts. So we've got, cliffed coasts here. Basically means coasts that have cliffs, as opposed to beach profiled coasts where they've basically got a beach. We might think we're seeing an erosional coast where mainly stuff is being taken away. We might be seeing maybe a coastline that's made of soft rock versus one that's made of high rock or hard rock, resistant rock here. A low energy coastline where we've basically got depositional activities occurring or transport, where as opposed to a high energy coastline here where we would see a lot of erosion occurring. We're going to learn what Hath and Dalmatian coasts are later on in the lesson, and you might also be thinking about submergent and emergent coastlines here, where the coastline appears to appear from the sea because the sea level is falling, and or submergent coastline, which appear to be sinking into the sea because the sea level is rising. So first of all, we have the first categorization, I suppose, will be high energy and low energy. And you can see in this table here, table 3.1 on the slide, it shows you the typical characteristics of low and high energy coasts. And it's worth pausing the video at this point to make a quick note of the kind of characteristics of low and high energy coasts. And here you can see two examples of high and low energy coastline. So we have the East Anglian coast here on the left with all its pictures here and its location. So East Anglia is obviously, here's London, and we're just down here in Esher, aren't we? And the East Anglian coast comprises parts of Norfolk, the county of Norfolk, the county of Suffolk, and the county of Essex, and includes this coastline here, which joins the North Sea and the Wash here, which is this very unusual shaped square bay, large bay, and where the River Thames comes in here to London. So this is the kind of Thames estuary here. So we have these typical low energy coastlines around the East Anglian coast. Featured, typical features include sand dunes like this with calm waves and kind of low angle beaches made of shingle. Or here we have kind of quite a very, very low lying piece of flat land that's clearly flooded. So we might have some marshland here, salt marsh, long sandy beach here. You can't see really from the angle of the waves here, but I imagine there is a lot of transport going on this cliff. Here we do have some cliffs here, but you can see from the greenery here along this bottom left photo, you can see the green areas on the beach are basically where the cliffs have slumped down. If we now turn our attention to the Atlantic coast of Scotland, here is Scotland. Obviously, I hope you realise it's stuck onto north of England. It's stuck onto here. The capital of Scotland is Edinburgh, and we are talking about the Atlantic coast, which means the west coast of Scotland. The east coast of Scotland is in the North Sea, or the North Atlantic. The west coast of Scotland is in the Atlantic. The Atlantic, obviously, it has a long fetch, so the waves travel a long way, because between the north coast of Scotland and Canada there is just ocean, basically, so that there's nothing in the way to slow the waves. So we have with this Atlantic coast here, high energy, big waves, and you can see lots of kind of cliffs, rocky features. Also, obviously, the geology is having a factor here. It's not just the fact there are big waves, it's a high energy coastline, but the rock is obviously very resistant. We have high land here, we have cracks you can see in this top picture, we have caves, we have a rock platform that's sticking out to the sea there, and we see in the bottom right picture we've got a lighthouse there, which is warning, because there would be a lot of shipwrecks in this area, warning people away from the cliffs, because obviously if you sail your boat into that, your boat is no longer any use to you. So what I want you to do now is draw two quick, either make a little table in your notes of high and low energy coasts, and your example of the high energy coast is obviously the Atlantic coast in Scotland, and your low energy coast here is the East Anglian coast. And then these blue characteristics here, I want you to put them in the right columns, basically for the type of coastline. That should be fairly straightforward. Remember that you may need to look up some words if you've forgotten, or you'd never covered it in GCSE, or you didn't do GCSE geography. Constructive waves put material on the beach. They're constructive. They are, they're helpful to beaches. Think of it that way. Destructive waves take things away from the beach, so they're big erosional waves. Fetch, remember the definition of fetch was the distance over which the wind blows to make waves. So if you've got a long fetch, generally speaking, you have much bigger waves. So have a little think about where you might put these factors. If you get really stuck, you need to send me a message, but you could have a look in the textbook. That would also help you. Now, another category of coast, apart from high and low energy, is our discordant and concordant coastlines. You may have come across this before, but you may not. So we have a discordant coastline, which is indicated on the right hand side of this image here with the headlands and bays, typical features of discordant coastline. Discordant, if you've got discord with somebody, you falling out with them. So discordant coastlines, the rocks basically tip into the sea. So they are at right angles to where the sea is, right angles. So the rocks go this way and the sea is here, right? Concordant coastlines, the rock basically is parallel to the sea. So this is a concordant coastline here, and this is a discordant coastline. So we're going to have a look at some of the features that are associated with discordant coastlines, and then we're going to look at some of the features associated with concordant coastlines after that. So here is a part of the Dorset coastline. So the Dorset coastline is along the coast. So if you think about going south from Esher, you would end up in Sussex, which would give you the Sussex coast. In the next county along from Sussex, you've got the Hampshire coast, and then you have the Dorset coast. Many of you will have been to the Dorset coast either on holiday or you will have been on a geography field trip. So here we have a discordant example. So this is a discordant example because you see here these rocks in Studland Bay, Ballard Point, Swanage Bay and Dalston Head are running at 90 degrees to the ocean. So they come towards the sea. They're not with the sea, they come towards the sea. So depending on what type of rock you have, when you have these alternating bands of hard and soft, you get typical features. So when you have hard rock, you get points, which are bits that stick out, and heads, which are headlands. So this is made up of, in this case, we have the yellow here, which shows chalk, a hard rock, a point. The sea will find that difficult to erode. Dalston Head here, also made of hard rock limestone sticking out into the sea, whereas in between the bays, Studland Bay, which is very big, is made of very soft clays and sands, and Swanage Bay, which is not as big as Studland Bay, which is enormous obviously, but Swanage Bay here has been eroded away by the ocean. And here you can see this on the aerial photograph here, the satellite photograph of the same region. So we see here the point, we see here the head, we see here Swanage Bay, and we see here the big bay in Dorset here, which is, so that's soft rock, and we see Poole Harbour here, Poole Harbour. This is another example of a discordant coastline, and this time this example is taken from West Cork in Ireland. West Cork in Ireland is in southwest Ireland, so again facing the Atlantic Ocean, like we saw in Scotland. So it's facing the Atlantic Ocean, so subject to large waves which have travelled across the Atlantic from America. And here we see again alternating bands of hard and soft rock. So the dark green on here is sandstones, which are sedimentary rocks, but in this case are quite resistant. They might be very compacted for various reasons. And in between this paler green, but not this green here, this medium green colour here at Dingle Bay, Kenmare Bay and Bantry Bay is a less resistant limestone, which obviously the sea has been able to erode, which is why we have these bays. They're very deep bays, as you can see, but that's because the band of soft rock is relatively shallow. So you're obviously going to have a deep bay. The sea will find it a lot harder to erode the hard sandstone than it will to erode the limestone. So this is another example of a discordant coastline that you could use to talk about in your examples. Now we have a few examples coming up now of concordant coastlines. So this is a different section of the Dorset coast. This is the Lulworth section of the Dorset coast, which you may have had the joy of going to on a geography field trip. You're not going to do the tasks, ignore that, you're just going to listen to the video. So basically you see Lulworth Cove here, you see concordant, i.e. the same direction as the sea, they're parallel to the sea, they're not at right angles, and you see these alternating bands of rock. So again, we have the guide here, the key, which tells us what type of rock they are. So we have this yellow rock at the entrance to Lulworth Cove, which is Portland stone, very, very resistant limestone, used to build St Paul's Cathedral. So that's lasted a long time. It even survived the Great Fire of London, so it's a very resistant rock. So you basically, the sea has only managed to kind of erode a little bit of that over a long period of time, but once the sea had passed through that Portland stone there, maybe because there was a crack in the rock or something, it very easily passed straight into these softer rocks behind. So we have the Purbeck beds, the Wealden beds and the green sand, which were quickly eroded into this cove. Now, why didn't the sea keep eroding back in this direction from the sea inland? Because at the back of Lulworth Cove, we have this pink rock, this chalk. So it's very resistant rock, which forms towering cliffs. So basically, Lulworth Cove is this lovely shape because the sea's come in here, eroded back through the soft rocks, met the hard rock at the back and can't really go any further. So we have this lovely, I mean, it will go further, but very slowly. So we have this lovely, beautiful cove, which many of you may have been to. You can see Lulworth Cove here on the OS map, and I'm going to talk a little bit through some of the features on this OS map now to make sure that you understand how to interpret them. If you have done your Duke of Edinburgh Gold, you can skip this bit of the video because you will already be able to read a map. If you haven't and you want a recap on OS maps, I'm just going to quickly talk through some of the features. So skip forward if you know what you're doing. Otherwise, you're still with me. So here we have Lulworth Cove. You can see it here. It's labelled. This star means it's a tourist attraction. So we have Durdle Door here, which we saw a picture of earlier. So these dark pink sections that are all along this coast here indicate steep vertical cliffs, and we know that that's made of a chalk because we know it's made of a resistant rock, so we've seen it on the geology map. These pink lines all over the map are contour lines, and the closer together the pink lines are, the steeper the land. Now you can see numbers on these contour lines here. You can see 168 here at the top of Bindon Hill on the right of the map in grid square. Basically 983. You can see Bindon Hill there with a fort on the top, which would have been a defensive fort maybe in the Bronze Age. And you can see the number 168, so you know that's the top of the hill, because if you go down the hill in the north direction, you get right down to 75, 74, and this settlement here in the basically northeast of Lulworth Cove. You can see these purple kind of access roads, which are showing you how people might get to the beach. The green dotty things are paths. If it's just green little like hashes, then that's a normal footpath. If it's got diamonds on it, it's an official path that's kind of mapped. So this is the Southwest Coast Path. The Southwest Coast Path goes all the way around the southwest coast of the United Kingdom. So it was made famous in a recent book that you may have read. But anyway, we see here the bull, the blind cow, and the calf out on the left-hand side of the photograph in the sea. These will be stacks and stumps that have been left behind by erosion. Basically, there's stacks and stumps out in the ocean made of this resistant chalk material, which we know is there because we've looked at the geology map, so we know. So you can see a number of other features on this map. A red triangle means a youth hostel, which you can see there in West Lulworth. Police station, also in West Lulworth, which says Polster Police Station. A beer glass sign is obviously a pub. A tent and caravan sign at Eland's Farm is a campsite. And a telephone is quite obviously a telephone. It's a bit old-fashioned, that, because maybe we don't have public telephones, but in villages perhaps they still do. If you see a cross on top of a square anywhere, that is a church with a tower. So you know these are quite small villages. You can see to the north of the map in grid square, well, it would be grid square 882, above the word pit, and then dis, which means disused. It would maybe old chalk pits. You would see a triangle with something on the top. I think that's a pylon. Shows where the pylons are that carry electricity. And there's various other features on here. If you are still confused by OS maps, despite my quick tour, then go to the Ordnance Survey website. Just type in Ordnance Survey into Google, and there are lots of little tutorials there which are aimed at Key Stage 3 students. I understand that might be embarrassing for you, but if you want a recap on six-figure grid references or on features on a map, then that's what you will need to do, so that you do not miss any essential points when you are looking at data response. So here we have another type of concordant feature, and these are known as half coasts. Half coasts are concordant coastlines. The word half refers to all coastlines that have this shape, where they're concordant, where you basically have long spits of sand with alternating with lagoons, like we have here in the bottom picture. We have a long spit of sand alternating with a lagoon. So anywhere you see this feature in the world, it would be referred to as a half coast. But where the name half comes from is from the Baltic Sea, the southern shore of the Baltic Sea. in parts of East Europe. They're basically, half is the word for a lagoon. A lagoon is a landlocked sort of a body of water that's full of seawater that is not the sea. So it's like a lake behind the sea that's made of brackish or salt water. So this is a concordant coastline again. In the top satellite image there, you can see we have a long spit running across the ocean in the front of the lagoon. It is a spit rather than a tombolo for the eagle-eyed among you, because it does actually run all the way from this section of land on the east over to this section of land on the west, but there is it is not joined, so it almost is, but it isn't quite. So this is like a concordant. It's in the same direction as the sea. We have not got the sea eroding into a bay here with resistant and non-resistant rocks. We've got a depositional feature going on here. Another type of concordant coastline is a Dalmatian coast. Again, all coasts that are like this are called Dalmatian coasts. They are named after the original coastline in Croatia, which is called the Dalmatian coast. The Dalmatian coast of Croatia is also a concordant coast, but unlike half coasts, which are basically made of sand and they are depositional features, Dalmatian coasts are basically made of harder material where the sea has submerged lower lying land in between. So if you imagine that the land originally in Croatia extended out to where these islands are, what has happened on this Dalmatian coastline is that the sea level has risen after an ice age, and we have these what look like islands off the coast of Croatia, but which are in fact bits of high land that stick out above the rest of the land, and the sea has submerged the land around them. But you can see again, this is a concordant coastline because the rocks, the islands are running parallel again to the main coastline. So they will be made of the same rock, running in the same direction, basically the same kind of angle as the sea. So they're running along the sea. So we do not have headlands and bays here. We have kind of these lots of little islands. They look like islands, but they are actually higher, like raised parts of land. If you're still confused by half and Dalmatian coastlines, they do occasionally come up on the syllabus, but only on the exam, but only maybe for a 4 mark or an 8 mark maximum. You could refer to Dunn textbook page 114, or you could do a little quick Google of Dalmatian and half coastlines just to make sure that you have got both of those things in your mind as types of concordant coastline. So that's the end of the lesson. So hopefully you now understand what a high energy coastline is, what a low energy coastline is, what a concordant or discordant coastline is, and maybe have an awareness of other factors that might separate coasts. So we'll be looking at some more kind of classifications of coast later on. We'll look at cliffs, we'll look at beaches, we'll look at coasts that mainly have low energy environments in more detail. But these are kind of top level views of how you might classify types of coasts. So you can leave it there for now, and I'll see you next lesson.